you guys again. The common difference is the thing you add to each number to get the next number in the sequence. So you can see, how about, do you mind moving on to the next slide? Thank you. So, here's the explanation. 29 plus 5 equals to 34. 34 plus 5 equals to 39. And so it is clear that the common difference is in fact 5. So to get the next number in the sequence, we add 5 again. So what is 39 plus 5? As Justin said, it's 44. Yeah, Jasper also said it. It's 44. Good job. And we continue to add 5 in the sequence. So 44 plus 4 is 49. 49 plus 5. Oh, sorry. 44 plus 5 is 49. 49 plus 5 is 54. 55 plus 5 is 59. 59 plus 5 is 64. It's like a rap, right? But the two answers to this question, this problem, is 44 and 64. Good job. Example 3. Número 3. All right, let's see. So we have the sequence 12, 14, 16, 18, 20. Now, this time, 20, not 22, 20. But this time, I want you guys to do something different. Instead of guessing the next number in the sequence, I want you to first tell me the formula of the nth term of the sequence. And also, I want you guys to tell me what is the 99th term of the sequence. All right, it's not the next term, but the 99th term of the sequence. That's a bit challenging, but I have faith in you guys. So I'll give you guys. So Jasper, we're looking for a formula, right? Where the number will be expressed in n. So I'll give you guys 1 minute to try solving this question, and after 1 minute, I'll reveal the answer, or even sooner if you guys get it. Oh, all right. I think it's time for us to reveal the answer. So what does it mean exactly to express a number in terms of n? So let's take this number right here. Let me change to a more apparent color. Let's use this sequence as an example. If we're expressing it using n, and n represents the nth term in the sequence, the formula would be 12 plus n minus 1 times 2. Let's add that times symbol here. So you guys can try plugging in numbers and see if it's correct. Actually, let's try plugging it together. All right. So let's do the first number in the sequence. For the first number, n equals to 1, right? Because it's the first number. So because n equals to 1, n minus 1 equals to 0. And 0 times 2 is still 0. So you get 12 plus 0, which is 12. Did you guys all understand that? Or do you want me to explain more on how I plugged in the number and got the answer? We're all good? Well, let's try the next one. So the next one is 14, right? The n here equals to 2 because it's the second number in the sequence. So 2 minus 1 is 1. So 1 times 2 is 2. So the equation becomes 12 plus 2. And we get 14 from this, which is still correct. So that's how you do the question. Now, the thing I just wrote here, 12 plus n minus 1 minus n minus 1 times 2 is the correct representation for the nth term, but we can write it in even more simple terms. So let's expand this. Because right now we have n minus 1 in brackets times 2, right? If we want to expand this, it becomes 12 plus, what's 2 times n? 2n, right? 2 times n is equals to 2n. Minus, remember it's minus here because you have the negative sign here. Minus 1 times 2, which is negative 2. So, oh, why is it looking so unapparent? So the answer would be 12 plus 2n minus 2. But we can, and if we subtract the 2 from 12, we get 10 plus 2n. That is how we represent the nth term. Did you guys all understand what I did? Yeah. Okay. Now, here comes the fun part. We're trying to find the 99th term, right? So to find the 99th term, we need to plug in the number. For the nth term, the current n is 99, correct? It's 99, right? Because we are trying to find the 99th term. So Joyce, can you tell me what is the answer to this problem by plugging 99 into 10 plus 2n?
Help.
No?
Help.
Help? Okay, let's do it together. Or Justin or Jasper, do you yeah, of course, you guys can use a calculator. You don't have to do it mentally, right? Yeah. I don't require you guys to be like expert arithmeticians. 200 is 208. Great, Jasper. That is, in fact, the answer. So if you need the assistance of a calculator, plug 2 times 99 into your calculator, and you'll get oh, let's use green here. You'll get 198 as the answer. What you need to do right now is plus 10, because 2 times 99 equals to 198, and then we add 10 for this part right here, and do a little simple math. We get 208. That is the answer. Did you guys all understand that? Oh, Jasper, you're lagging again? Well, why did we add 10? Okay, so remember how we derived the formula for the nth term? Did you understand that part, Jasper? Yeah, okay. So the nth term basically means the nth number in the sequence, right? And what we need to do here is, in fact, really, really simple. Don't overcomplicate it. Just plug 99 into n, because we're trying to calculate the 99th term. So n here equals to 99. And as we know, 99 times 2 is 198. Right, Jasper? Yep. Okay. But we're still not done yet because we still have a 10 here. We still have a 10 here. And so what we need to do here is we need to add 10 accordingly to the equation. So our final answer should be 198 plus 10. Therefore, we get 208. You understand that, Jasper? Yeah, okay, let's go. All right. Does anyone else have any questions? If you have any questions, just say it and I'll explain it. Okay, so I think everyone seems to be good with what we have. Let's move on then. So a quick generalization. Now, arithmetic sequences might seem a bit complicated, but there is, in fact, a formula, which is something you could figure out by plugging in different numbers, a formula that specifically summarizes all of the patterns in a sequence. And it's called the arithmetic sequence formula. It's used to find the nth term in an arithmetic sequence. The sequence looks like this, and you might wonder, why do we have so many letters, right? We're not even in an English class. Why do we need so much letters? Well, let me break down the letters one by one for you. It looks annoying, but it's actually pretty easy to understand. So A here represents the first term in the sequence, right? Just like how A is. Oh, okay. So Hemel is typing a quick example for us. So A here represents the first number in the sequence. You can remember it as, A is the first letter in the alphabet. So A here represents the first number in the sequence. What is D? Well, D stands for the initial letter of something, a concept we covered in the slides before. D is the common difference, which is the difference between each number in the sequence. Oh, and yeah, in this example, A equals to 1 because it's the first number in the sequence. D, which is the common difference, equals to 2. Why? Well, for each number, to get next number in each sequence, you add 2 to each of them. So D is the common difference. And here we have n minus 1. N is something we covered before. It's the nth term, right? It's the nth term. It's a term that you're trying to find. So n minus 1. Well, some people might wonder, well, David, why is it n minus 1 instead of n? Like, why do we have n minus 1? Well, let's take a quick look here. So the common difference, you can see it as the number being added to the subsequent number in a sequence, right? For the first one, it's just 1. It's just A, right? You're not adding any difference because it's the first number, so there's no difference or whatsoever. It's just simply A, or in this case, 1. For the second number in the sequence, you're adding 1 difference, right? Because you went from this first number to the second number. So we're adding it by the difference. Now, what do we times the difference by? Well, we times it by 1, right? Because we're only adding it really once. So we're using n minus 1 here because we see that, well, n is 2, right? We're on the second number. But what we're really doing is that we're only adding the difference by 1. by like not like by 1, but by 1 time. So it's n minus 1, which is 2 minus 1 for the second number, which is 1 times the common difference, which is 1 times the common difference. The common difference is 2. So we get 1 plus 2, and we get 3. For the third number, what is the third number? Well, the third number, you can see it as the second number plus the common difference, right? It's the second number plus the common difference because you're adding the common difference by 1, you're adding the common difference to each number to get the subsequent number in the sequence. Well, if we're adding same common difference to the second number, what can the second number be written as? We think about the second number as the initial number plus the common difference, right? Let's call it D. To get the third number, we have to add, oh, this looks like an A, but all right, this is a D. Just remember it, it's a D, guys. So to get this third number, we have to add this common difference yet again. So we're adding the common difference again. So this time we're having A, the initial number, D, the common difference, and D, the common difference again. So we're adding it by 2 times, right? The third number, you can see it as the component, this part as the initial number. This part is the initial number. I mean, not like the initial number. This part is the second number, and you're adding it by the common difference. And the second number could be split into the initial number plus the common difference. So therefore, we can write this as A plus 2D, which is 2 times the common difference. Now, strangely enough, 2 is 1 less than 3. So again, it should be n minus 1 times D plus A, which is an initial number. And the good thing about this thing is that, about this formula, is that you can find any number in the sequence as long as you're given 2 numbers in the sequence. All right. Say if I give you 1 and 3. Let's use this as the example. Wait, before I continue, did all of you guys understand what I just talked about? Did you guys understand why it's n minus 1, but not n? Justin, Jasper, Joyce, are you guys all clear? Kind of, yeah. Jasper, which part do you not understand? Like, which part do you have still have some questions about? Do you want to turn on your mic? Oh, let's go back. -1 becomes -2. No, it's not. -1 becomes -2. It's always -1, right? So let's say we're using the sequence Hembo gave us. 1, 3, 5, 7, 9. A is the initial letter. I mean, not the initial letter, the initial number. So it's 1. For the first one, you have 1 plus 2, which is a common difference. See, because there's 2, 2, 2, 2. The common difference times n, which is 1 minus 1. Right? So n equals to 1. 1 minus 1 is 0. 0 times 2 is still 0. And 1 plus 0 is 1. So we get the first number in the sequence is 1. For the second number, we have 1 plus 2 times this time n equals to 2 because it's a second number in the sequence. So it's 2 minus 1. Jasper, what's 2 minus 1? It's 1, right? 1 times 2. What's 1 times 2? 2. Good. And so we just add these things together like we're on an assembly line. And we get 1 plus 2 times 1, which is 3. So this thing, so the thing you're minusing it by does not change. What changes is n, because you increase it by one time, increases it each time. So a and d here are all constants, which is basically like constant numbers you have in an equation. N here is a variable, which means it changes over time. So like really, I mean, the only number changing here is n. All right. Let's move on. It's a bit tricky, but okay, here comes the fun part. So considering the following sequence, 5 to -1. Wait, hold on. Negative numbers? Yes, thus a sequence can indeed have negative numbers. It's not something you should be scared of, because just deal it as if you're dealing it with the positive numbers. Negative numbers, positive numbers, it's not that different. So when you see negative numbers in the sequence, don't panic. Just solve it as if you're solving positive numbers. So the first question, A, what is the formula for the nth term in this sequence? How about I give you guys 1 minute to try and solve this question. After 1 minute, thus the answer for question 1, part A. All right, did you guys get the answer to the sequence? I mean, for the nth term formula? Okay. It's actually not that hard. Let's look at it. So 5. Okay. So 5 is an initial number, right? If we remember the equation, it's supposed to be a plus d times n minus 1. That is the equation, right? That's the formula. That's the thing you're supposed to use to find the nth term. So a here is the initial number, so it's 5. Now the common difference, if we see, it's actually a negative number. It's -3, right? Because you're minusing it by 3 each time, so it's a negative number. So it's -3 times n minus 1. That's the equation for the sequence. Now, if we do a little simplification, it becomes 5 minus 3 times n, which is 3n. -3 times -1, we have to be careful here. That becomes a plus 3. Remember, double negative equals to positive. So we get 8 minus 3n. That is our nth term. Did you guys all understand that? Joyce, Justin, Jasper, did you guys all understand that? All right, let's move on to part B. So what will be the 139th term in the sequence? Well, this one is fairly easy. You just plus 139 into n. And do you guys want to attempt this question yourself, or do you think I should just reveal the answer? Sure, reveal the answer, or sure, as in attempt a question. Okay, Jasper, I'll give you 1 minute to do it. Remember, you can use a calculator. So 425. I think you might be off, Jasper, because it's supposed to be a negative number. Wait. I think what you did here was that you yes, it's supposed to be negative 409. That is indeed correct. I think what you did here was that you saw the negative, the minus symbol as a plus symbol, which is not correct. All right, we have negative symbols in an equation. So 8 minus 2, 3n, which you plug 139 in, you get 139 equals 3 times 139 equals to 417. So 8 minus 2 minus 417 is indeed 409. So I mean negative 40. So you guys are, Jasper is indeed correct. All right, good job, guys. Now I'll have to leave, but have fun in the math circle.
All right, so we're running a bit short on time. We have like another big section. So do you guys want to also attempt number 2, or should we just skip it and go on to the new material? Let's take a quick vote. What do you guys want to do? I don't know. Okay, well, that's a 0-0 on both sides. Joyce, Justin, what do you guys want to do? Do you guys want to try this problem, or let's move on to a different concept?
Move on.
Okay, so, well, this is the sequel, I guess, right? So after you have sequences, you can talk about series, which is much more interesting than simply an arithmetic sequence, because, well, it might not seem so interesting at first, but I promise it's going to be interesting. So indeed, if you can read from the slides, yeah, a series is just a sequence added up. An arithmetic series is really just the sum of the numbers in an arithmetic sequence. So 1, 5, 9, 13, 17, 21, that's an arithmetic sequence. We've been talking about that for a little over half an hour. And 1 plus 5 plus 9 plus 13 plus 17 plus 21 is an arithmetic series. So you see the difference is pretty easy. So I'm going to first present to you the formula for evaluating the general arithmetic series, right? So it's basically the number of terms multiplied by the sum of the first and last term, all of that divided by 2. So in other words, this n here is the number of terms you have. A1 is the first term, and an is the last term. So for example, if you had 1 plus 3 plus 5, the number of terms would be 3. A1 would be 1, an would be 5. Technically, it's pronounced a sub n, but you get the idea. Sorry, this is a 5, right? But, you know, this isn't really the interesting part. I think that really the interesting part is how we got this formula, right? So here, I'm going to show you guys exactly how you can derive this formula for your very self. And in fact, I'm going to see if I can get a whiteboard real quick to, 1 second, ladies and gentlemen. All right. Can you guys see this whiteboard over here? Can y'all see this? I'm gonna draw a little. Yes, okay, great. So let's say I have this arbitrary series 1 plus 3 plus 5 plus 7 plus 9. And let's call it S, right? Okay, so series S equals 1 plus 3 plus 5 plus 7 plus 9. But now watch what I'm going to do. I'm going to write S instead as 9 plus 7 plus 5 plus 3 plus 1. Well, we can all agree that the value of S is still the same, right? You're simply shifting the numbers you're adding around, but the numbers you're adding are still pretty much the same. So now the interesting part comes. Watch what happens if I do this. What would happen if I added these two rows together? Oh no, where's my whiteboard? There it is. So, okay, so what would happen if I added these two rows together? Then I would get 2s equals what? Equals 10 plus 10 plus 10 plus 10 plus 10 equals 50, right? So that means s just equals 25. That's such an easy way to calculate it, isn't it? And you see the key part here is how we reversed the order of s and then added it with the original series, because now every term is now a 10. So we can simply multiply 10 by 5 to get 50 and then divide by 2 to get the original series. So why am I talking about this idea? Well, you see, this is how we can derive the general formula for evaluating a series. Because now instead, let's say s is equal to a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n. Again, we're going to reverse it. So s is also obviously equal to an plus a n minus 1 plus a n minus 2 plus dot 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 plus a 1. And again, you know, from the example, all of these are going to add up to be the same number. And if you think about it, it does make sense, because if you go from left to right, a1 to a2 adds a common difference. An to an minus 1 minuses a common difference. So that means all of these vertical terms are always going to add up to the exact same number. So that means 2s is simply equal to the number of terms times a1 plus an. So you can simply divide that by 2 to get the formula that we were talking about earlier, which is right here. So yeah, that's how you derive the formula for calculating a general arithmetic series, which I find to be very interesting. Again, let me know if you have any questions about this, but now let's put this formula to use. So here, example 1, evaluate the following series. It's pretty easy. I'm not even gonna ask for a response. So we simply add the terms together, but alternatively, you can also use the formula. So again, the number of terms is 5, which is why we have a little 5 here. And then the first term is 5. So here, last term is 21. Divide by 2. 5 times 26 over 2 with 65. Pretty simple. Pretty straightforward. So now consider this problem that's tiny bit more challenging. So consider the following sequence: 13, 16, 19, 22, 25, dot, dot, dot. This sequence keeps on going and it stops at exactly 30 terms. And now the challenge is to evaluate the sum of the terms in the sequence. So what do you guys think should be the first thing that we do when solving this problem? Like, what's the big thing we have to do so that everything else will be easy? Give me some ideas. What do you guys think? Like, what's the first step to calculating the sum of the terms of the sequence if you add all of them up? Nobody has any ideas? We're all stuck. Justin, you got anything? What do you think we should do? Like, how do we solve this? No, nobody has any ideas. Okay, well, we can solve this problem obviously with our little formula from earlier. The only thing we're really stuck on is we don't know what the 30th term, right? Because if you recall the formula here, you need 3 variables. You need the number of terms, you need the first term and the last term. Looking at this problem, we know the number of terms. It's just 30, right? We have 30 terms. We know the first term, it's 13. So all we really need to know is what the 30th term is, and we can simply just plug and chug and press buttons on a calculator to find the answer. So indeed, that really is the singular challenge in this problem. So how do we find the 30th number? But I think we just learned how to do that, right? A while ago, because that's simply the arithmetic sequence problems we're doing. The nth term, again, in general, is a plus common difference times n minus 1. So the 30th term is simply 13 plus 3 times 29 equals 100. Because if you recall, the first term is 13 and the difference is 3. So the 30th term is 100. We then apply the formula, 30 times 13 plus 100 over 2. That gives you 30 times 113 over 2, which is 1,695. Okay, before we move on, are there any questions? Because y'all are pretty silent. Jasper, do you understand everything? Is there anything you're confused about? Joyce, do you have any questions? Justin, is there anything that doesn't quite make sense? No, everything makes sense? Okay. Okay, that's good. All right, here's example 3, which is pretty hard. So consider this arithmetic sequence. This sequence goes on pretty long, and it stops at exactly 121 terms. So your challenge is to evaluate the sum of the terms in the sequence. And obviously, you are allowed to use a calculator. I'll give you guys like 2 minutes, 3 minutes, see if you guys make any progress. But if you're like absolutely stuck, you're making absolutely no progress, just type "I don't know" in the chat. And if everyone is "I don't knowing," then we'll just move on. So go ahead, give it a try. Why does the denominator turn from 2 to 6? No, that's a great question, because it's a simplification. So it's really -3 over 6. But since they share a common factor of 3, we can divide it, simplify it 1/2. But it's really, yeah, it's -3 over 6. So you can just look at that instead and cross this out. Well, since no one's I don't know, I'm assuming we're making pretty good progress, huh? Did anyone get the answer? I don't know. Okay, Jasper says I don't know. Joyce, Justin, what about you guys? Joyce, what should we do to solve this problem? Justin, you got any ideas? Does anyone of you have an answer?
Nope.
Okay. All right, well, negative 4,961. Ooh, I wonder if that's right. Let's see. Justin, I think you forgot to divide by 2. But you did everything else correctly, though. Oops. But I mean, good job. That's like 99% of the work. You messed up on the last 1%. That's totally fine. All right, well, let's quickly go over this again, shall we? So again, the biggest challenge is finding the 121st term in the sequence, right? Because we have the number of terms, right? We know that there's exactly 121 terms. We know the first term, so the challenge is really just finding the 121st term in this sequence. But I mean, hey, we know how to do that, right? Because since the first term is -1/2 and the common difference is -1/3, we know that the 121st term is simply -1/2 plus the common difference, which is -1/3, times n-1, which in this case is 120. And again, you can think of it as like, to get the second term, you got to add the difference 1 time. To get the third term, you got to add the difference to the first term 2 times. So that means to get the 121 term, you got to add the difference to the first term 120 times, right? So that means you do that and you get that the 121st term is -81/2. And then it's just all calculators. So you apply your formula and you find that the series evaluates to -2480.5, which is exactly -4,961/2. So yeah, are there any questions? Does this make sense, Joyce? Do you understand this? Do you have any questions?
Okay.
Okay, well, let's test that. Okay, shall we, Joyce? Why don't we try this first problem? Consider the following series. Now it's a slightly different challenge. How many terms are in this series? And when you find that, calculate what it evaluates to. So I'll give you another like 1 or 2 minutes and try it out. If you don't know what to do, I don't know in the chat. Go ahead. Does anyone have any ideas? Does anyone make any progress? Jasper, you got any ideas? Justin, are you making any progress? Or are we all stuck? But I don't see any idea. I don't know. So okay, he's working. Okay, okay. $60. All right, Justin. Jasper, Justin got his answer. Are you close? Meanwhile, Justin, why don't you calculate what evaluates to? I think Justin just dropped a hint in the chat, guys. Justin just dropped a hint in the chat. Hey Jasper, how's it going? Are you close or are you stuck? Okay, I'm gonna almost. Okay, Jasper is almost done. Joyce, how are you doing? Are you stuck or what? Are you making progress or? Joyce, how are you doing?
Not good.
Are you completely stuck?
Yes.
Oh, okay. It's fine. We'll just wait for Jasper and then we'll give the big reveal.
Okay.
Jasper, no pressure. Jasper, I'm gonna give you 60 more seconds. If you can't work it out, work it out. But if you don't, we're gonna have to. On. Okay, I'll give you 90 seconds starting from now. Okay, I'll give you 90 seconds. Because we're running a tad bit short on time. So I'll give you have 80 seconds left. Everyone, you guys can like chill for a bit. Chill for 70 seconds while Jasper works out his problem. $61. Oh my god. Jasper, I think you're really close. Might be 60. Well, I mean, you have 40 more seconds. Go and check, Jasper. Is it 61 or 60? Go check, go check, go check. You have 30 seconds. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. Well, no, Jasper, it actually turns out to be 60. Justin is indeed correct, because I also solved it and it's 60. So, well, here, I'm gonna show you how to do it. Okay, it's fine. You're very close. You're like off by one. That's great. So, as Jasper dropped the hint, we understand that it's really just a bit of algebra, right? We're still using a plus d times n minus 1. And this gives you the nth term in this formula gives you the nth term in the sequence, right? So since we're trying to figure out the number of terms in the series, what we're really trying to figure out is like, what number term is 304, right? Like, is it the 50th term? Is it the 49th term, or like, what is it, right? So we're gonna set this equation equal to 304, right? Because we're solving for the value of n, and that will give us the number of terms in the series. And furthermore, we know both a and d, because a is 9, while d is 5. So now we can really solve for n, right? This is our equation. Do some basic algebra. You get 5 times n minus 1 is equal to 295. And then you divide both sides by 5. Get n minus 1 is 40. Sorry, it's 59. And then finally, you add 1 to both sides. So n is equal to 60. So that means 304 is the 60th term in the series, which means that there are exactly 60 terms in the series. And so after we have that, everything else is just plug and chug, right? So now it's just 9 plus 60, sorry, not 60, 304 times 60 divided by 2, which is really just multiplying by 30. So that's just 313 times 30, which is 9390. And that is the answer to number 1. So yeah, Justin, you got it right. Jasper, you were so close, but good job. We don't have time for problem 2, but you're more than welcome to try it if you want to. The slides are already in the WeChat group chat, so you can check that out as well. But otherwise, unless you have any further questions, you are free to go. And thank you very much for coming tonight, and good job.